manipulating formulas, solving equations. Solve for x, solve for m. Sound familiar? Manipulating formulas could be one step or two step, three step, who cares? Doesn't matter. The dance is still the same. And the importance of this skill to have as a mathematician in both math and science is absolute. You need it. So keep it simple. So let's learn some dance moves here in manipulating formulas. The first move that we need to make is understanding what it means to manipulate a formula. So to manipulate a formula, well, let's look at this. What does it mean? So from these two definitions, you can see that there's a progression. We sometimes say manipulate the formula, which sometimes means equations need to be solved for, like solve for a variable or isolate the variable. They all mean the same thing. Or they're related closely. But the two most important things that you need to realize here are the conditions. They as in the variable needs to be alone by itself on one side of the equal sign and in the numerator position, which would mean that if our variable is x, then it would be alone by itself. And whatever is written here, I don't care. But this is what it looks like. Once you check off these two conditions, then we've isolated the variable. Then we have solved for the variable. And that was manipulating the formula. But we need some vocabulary. So let's do that now. Here we have an example. 2x plus 3 equals 15. Now I've color coordinated what it means. These 5 different words will help us understand an equation or formula. First of all, what you need to know is the coefficient in red. This is a number that's usually attached to the variable. Variable is some unknown. The variable could mean anything, really. In this particular example, it can only represent one number, but it's unknown, and so we use a letter to represent it. The coefficient usually is multiplying or dividing this variable. Constants. Constants are the things in purple. Positive 3 and 15 happen to be two constants because in this equation, this doesn't change. You will always add 3 and it will always equal 15. So what x represents, well, I don't know. In green, we have what we call the expression. In this case, it's 2x plus 3. But in order for it to become an equation in blue, it requires the whole thing. It requires an expression that equals some sort of constant. So this is how we actually talk about an equation or formula. Now, in order to isolate the variable, remember what we said? This is not alone by itself. We need to focus on removing the different pieces of the equation. So in this case, let's just get a nice pen in here. What are the different parts of the equation? We need to get rid of this. And we need to get rid of this. We need to get rid of the positive 3 constant and the coefficient so that x is alone by itself on one side of the equal sign or isolated. That way we solve for x. So let's go through 2 examples here. We have a 1-step and a 2-step equation. So you're probably recognizing these terms, 1-step or 2-step said in there. Well, what does it mean? 1-step equations are a little bit more simple than 2-step or 3-step or 4. In this dance, for the 1-step, you only need to get rid of one piece of the puzzle in order to isolate the x or the variable. This is 1 step because all we got to do is get rid of this 2. For a 2-step, we need to get rid of a coefficient and a constant. That's 2 steps. Count them, uno, dos, in order to isolate the variable. Now, the way that we do that is by isolating, the way that we isolate the variable x is by opposite operations. How do we get rid of these things? Well, we got to get rid of the 2. Now, it's really dangerous to think in terms of getting rid of or disappearing or whatever. You are actually just rearranging or manipulating what this looks like. You're not getting rid of the minus 2. You're just relocating it. How do you do that? Opposite operations. Here's the golden box. So it's being subtracted, minus 2, so we need to add it. I should note right here, big fat note. very important to go in reverse order of operations. Sometimes it works out. Most of the time it does, actually, but it's a good idea. So I'm going to start with the adding and subtracting. This is being subtracted. So I'm going to add 2 to this side. But I don't know. Well, how can I do that? I give you the authority to do that. So plus 2. Now, if you take minus 2 and plus 2, that is a 0 pair. Okay, so these things are now 0. So we have x minus 0, or just x. And then we equal 5. But you see, now remember this. Whatever you do to one side of the equal sign, you must do to the other. So if I'm just going to add 2 over here, I've got to add 2 over to this side. And here's another huge thing to do every single time. Rewrite the equation after each step. So in this case, x equals 5 plus 2 is 7. So this is one step, and we're done. Okay? Let's get this pen going out purple. Let's do a 2-step. Again, order of operations is reversed when you're trying to isolate a variable or solve for x. So let's go for the adding and subtracting. Here's this constant being added, so I'm going to minus 3, and we're going to minus 3 because whatever you do to one side, you do to the other, and this makes a 0 pair. And so now what we are left with is, always rewrite x, 2x, this is a 0 pair, equals 15 minus 3 is 12. And you see how now that's one step gone, and now we have to do one more. So let's do this. We got to get rid of this coefficient. It's being multiplied. So multiplying, the opposite operation is dividing. So if we divide this by 2, but whatever you do to one side, you do to the other, divide by 2, divide by 2. Again, this is the way how we relocate these bits and pieces of our equation. Yes, 2 divided by 2 is actually equal to 1. 1 times x is just x, so this cancels out. But we're not disappearing this. We're not getting gone this 2. We are actually moving it over here because we did the exact same thing over here to what we did on the left-hand side as the right. So we rewrite everything. X equals 12 divided by 2 is 6. Now, another great thing to do is the following. Check your work. Now, I'm going to take this x equals 6, and I'm going to substitute it into this formula. So wherever there's an x, I'm going to put a 6. So this is 2 bracket times 6, oh baby, plus 3, and it should equal 15. Now, of course, we're working with actual order of operations, so let's do multiplication first. 2 times 6 is 12 plus 3. Does that equal 15? Son of a gun, yes it does. 15 equals 15. The good mathematician will always take their final work, their final answer, x equals 6 in this case, and substitute it back into the formula. We can do the same thing here.
Let's substitute this all the way back into the formula. 7 minus 2 equals 5.
Now, these were just 2 simple examples. Again, these are equations. These are with numbers. But guess what, people? You don't need numbers. An example is this formula. F equals ma. No numbers required. This is called a formula. In physics, this calculates for force. Force equals mass times acceleration. But you don't know what the mass is. You don't know what acceleration is. We want to solve for m. What does m equal? Maybe we're given f and a. It doesn't even matter. We can solve this or manipulate it all the same. Check this out. I want to solve for m. Is m alone by itself on one side of the equal sign? No. Is it in the numerator position? Yes. Those are the 2 conditions, remember? So m is in the numerator position, at least that's good. So we need to get rid of this a. How do we get rid of the a? Opposite operations. So it's being multiplied, so we got to divide by a, but whatever you do to one side of the equation, you do to the other. Sorry, that a looks lame, like a 9. So divide by a. A divided by a is 1, so these cancel out. Let's rewrite everything. M equals F, or force, divided by acceleration. Isn't that awesome? So here, we've just changed this formula so that we actually have, we can calculate for mass. And you're going to be seeing so many different formulas. All of these things. Here's a bunch of formulas. Solving for force, solving for work, solving for kinetic energy, potential energy, velocity, acceleration. If you can manipulate formulas, you can solve for any one of these variables. If you can solve for any one of those variables, you're well on your way to being an excellent mathematician in science. Get practicing. Dance on all night long.